Alright, update for September. So we've been going through some growing pains. We blew the hell up some traces. Just blown right the hell up. We gotta be careful because we're live right now, but so we bootstrapped that trace because that's the current trace, but we are just blowing traces left and right. This monster pulls a lot of current, just even from the wall, and I think even the AC cord's getting warm. But we're making some inroads. We're not quite back to the V set that I want. We're at about 45 volts, which is more than what the customer needs, but well, maybe we'll leave it at 45. I don't know. I had it going to 50 before, which is nice because this guy goes to 50. That's a pretty cool meter if you ask me. But we're on 2 ohms right now. She's getting hot. Yeah, she's hot. We're just doing a basic load checkout, torture test. We put a local remote switch in. What does that do? That disconnects the direct connection from the sense lines to the power, so you can compensate for line loss. You know, these lines aren't hot. We just made these today. I didn't want to burn up my Pomona leads. We're pushing 10 amps right now. Just this will push 10 amps no problem all day long. I don't know if the the cord to the house will handle it though, but we had some issues. I had the feedback lines to the pass transistor were flipped. I had to go back and check an older picture, got that rectified. Then I found out there's a bunch of, well, I damaged some little diodes and I took care of that. I didn't know what the hell was going on. Turns out I blew a couple of the diodes out. The V-set adjust pot was destroyed. I don't know about the I-set. I think the I-set adjust pot's okay because we're in I-set mode right now. That's what the red light's for. We're in CC mode at the moment, and I'll show you that as proof in a second. I just removed this dude. This guy was causing oscillation between pins 6 and 5 on the 741 that does the current control, and that's a known problem. I've known about that for a long time. I just designed back in the capacitors for both op amps because I'm stealing a design from what is it? It's an LG. It was Easy Digital, but also LG, the LG 50, the 5005 power supply. It's a really nice power supply. It goes up to 50 volts and 5 amps. I love that power supply. It's all analog as far as the control goes, and a lot of other designs are based on that too. They borrow and steal from each other quite a bit. Although my lamps are reversed for current and voltage modes. The LG has the green for the CC and the red for CV mode. But that's minor. We'll put that in. We'll do that. We can change that and we can fix it here. It's not really important at this moment. We're doing test out and torture test at the moment. We're idling right now. We went up to, I think it was 38 amps, and then we started blowing traces and all kinds of shit started happening. So we're cruising right now at 10 amps, 20 volts. And I'll take it out of, these are the V-set pots. We're in current mode right now, and it's no longer oscillating, which is, thank you. Thank the Pixies. since they're no longer slam dancing. So I'll show you where I'm only going to touch the current control. I'm not going to touch the V control. Okay. Now the voltage is going to go down as a result of the current, but I'm going to show you we have current control right now. You heard the relay click. That's the range relay. Okay, so didn't touch the other knobs. You can see the white line. I've only touched the current control. 10 volts, 5 amps. Okay, we're in 2 ohms. Right? Now I can go all the way up until we're in voltage priority mode or CV. Okay, now we're in CV. Okay. So we're at 30 volts, 15.4 amps. Okay, so the power supply's in CV. And I can turn the voltage down if I want. This is the coarse, this is the fine. We turn the voltage down. Oops, wrong one. Bring it down to 20. There we go, we're at 20 volts. 20 volts, CV mode. So you'd expect 10 amps, 20 volts, 10 amps, 2 ohms. Ohm's law. Okay, we can trim that because we're not quite 20, so we can trim that just a little bit here with the fine adjust. Okay, so we trimmed it with the fine the fine voltage set, 20 volts. Okay. Now we're gonna turn this all the way down. Okay, one of the cute things we're doing here to prevent the breaker from going. You watch the relay. You probably can't see the relay. But we've got an easy start. So this is or a soft start. This is my soft start. This tells you when the power supply is booted. It's not really booted because it's not really digital, but that tells you when you're ready. Yep. And the soft start prevents us from tripping the breaker all day long. But we still need to put in a disconnector to the pass transistor because when it turns off without a load, it's dumping the charge that's in the reservoir out the front, and we don't want to do that. That would be bad for whatever circuit you're testing. So we need to do some kind of a disconnector there, some kind of protect circuit that'll disable the front panel from coming out. And this is unless my customer really cares about that. I don't know if he really cares about that or not, but we don't want to blow up whatever he's testing. But I think we're doing okay. I think we're doing okay for now. We got the oscillation problem fixed. We still have to play more with the current because I'm not really sure where we need to be trimmed out for current. I think we're pretty good on the voltage. Might still need a little work there. Oscillations are gone. This is just the beginning of the torture testing. We have much more torture testing to go yet, and we still need panel meters. So we have ages to go yet on the final design here, and yeah, there's still a lot to do here. We're not. This isn't close yet. I think close is still quite far away. Well, thanks for hanging out with me.